What is a vector? A vector, by definition, is a quantity that has magnitude and direction. Now, what does it mean for a quantity to have both magnitude and direction? For example, I could have a number that just has quantity. I could say I am going 50 miles an hour. That would be a quantity, 50 miles an hour. But if I say I'm going 50 miles an hour on the highway going straight north, then I have magnitude and direction, and that's known as velocity rather than speed when it has magnitude and direction. Now let's think of something that has magnitude and direction. Forces have magnitude and direction. For example, let's say I have a heavy object. Heavy. I can't even spell it right. Let me try this again. I have a heavy object in this box or something, and it's going to take two people to pull this heavy object. And so we have a ring attached here, and we have two ropes attached to it. One here and one here. And let me make them different colors. Okay. And I have two people pulling on this object. One person is pulling this direction because they're standing right here. They've got to stand next to each other, so they need to kind of pull at an angle here. So one person's pulling this way, and one person's pulling this way at an angle from that ring on the box. Well, what's going to happen to the box when they both pull at the same time? Well, the box is going to end up going this way. And because they're both pulling on the box, the sum of their pulls will cause the force pulling forward to be greater than either of the individual sums, but not quite double the sums because they're pulling at an angle, so not all of the force they're using is going straight forward, only part of it's going forward. Another example is, okay, I'm trying to row across this river, so we'll pretend this is a river with some water in it, and I have a little boat, and I'm trying to, in kind of a boat-shaped thing, it's got some oars, you know, and I'm trying to row straight across the river. Well, is that going to happen? Well, no, because this river has a current, and the current is going this direction. So as I try to row across the river, the direction I actually go is more like this because the river is pushing me. I can think of the velocity of my boat as one vector and the velocity of the current of the river as another vector. When I add them together, I take the boat velocity, let me make that black like my boat, the boat velocity and the current velocity, and then the actual path that I row across the river looks more like that. That's vector addition. So vectors represent quantities that have magnitude or length and direction. The longer the vector, the bigger amount of something it represents, and the way I draw it, that's the direction. Now, I want you to notice something. I could pick this vector and move it over here, and it's the same vector. I can move a vector anywhere I want to, as long as it's the same, pointing the same direction, it's the same length, it is the same vector. So I could think of the current pushing here and the distance here and draw this same relationship that way, and it is the same relationship between the three vectors. Now we're going to learn about naming vectors, some notation for vectors, and some formulas for using with vectors, and then we'll do some examples. So let's talk about some vector formulas. We just talked about that we can add together vectors by having one vector here, and another go straight across. They don't have to be going at right angles to one another, but when they do, we say that the horizontal vector and the vertical vectors are the horizontal and vertical components of this diagonal vector. Notice these funny little arrow things. These are called vector hats. They are this little arrow, and that's just indicating that this variable represents a vector. It's kind of like drawing the angle with a vector. And by the way, I didn't talk about before, but a vector has a head and a tail. So the head is the side of the arrow and the tail is the side without an arrow. Whenever you add two vectors, like we did here, notice that I have to connect the tip of one to the tail of the other, and then the sum of the two vectors goes from the beginning of the first vector to the end of the second vector. Now, The x and the y here just represent what are called scalar or just numerical quantities. So that basically x just tells me how long this vector is. The little I represents that this is a vector going in the horizontal direction. So when I see the I, that's an x direction vector. A j is a y direction vector. If I have three variables, I could even have a z direction vector, a vector k, and I'd say xi plus yj plus zk, and k would be my z direction vector. And technically you can have vectors in even more dimensions than that, although that's a little beyond what we're going to be talking about. Now, to convert between to name vectors, I can name vectors by either labeling them as a sum of their components. Another type of notation, I could also just list the length of their components in order, x, y, with kind of pointed brackets, and that indicates I have a vector, and that these two things tell me the same thing. This tells me the x component and the y component of the vector. Now, another way I can name vector is by its size and its direction. So I could put theta here, and I could say that the length of this vector is magnitude. I denote that with these absolute value signs, or what looks like absolute value signs. So when I talk about magnitudes, I can say this is the length of vector v. This is the length of the vector that's the horizontal component, and this is the length of the vector that's the vertical component, and this is the angle of the vector. So I can name a vector, and I can say vector v is xi plus yj, or I can say vector v has a length of such and such at an angle of such and such. So we're going to be looking at both ways, and we're also going to be looking at how do you go back and forth between them. And hopefully you should look at this and go, these are right triangles, I can figure this out. If I know the vector's components, I can certainly figure out its magnitude using the Pythagorean theorem. So here is that relationship right here. If I know the vector's components, I can also figure out the angle of the vector because I can do tangent of y over x. And I'll talk about this part in just a minute. If I know the length of the vector and its angle, then I can find its components, because the length of its x component is found using cosine, because cosine of theta is x over the magnitude of the vector. Sine of theta is y over the magnitude of the vector. Solving the equations for x and for y, I get this. X is the magnitude of the vector times cosine of the angle. Y is the magnitude of the vector times sine of the angle. So all of these are just based on right triangle trigonometry. But what happens if I'm not in quadrant 1? That's where this part comes in. If I'm not in quadrant 1, if my vector has a direction that's in quadrant 2 or 3 or 4, then I have to make some slight adjustments. So let me show you what that second part of this equation tells you. So if I did inverse tangent of y over x, and here was my x and y components, notice this would be a negative number and this would be a positive number. I'd be doing inverse tangent of a negative number. Well, where does that end up? That's going to end up in quadrant 4. I'd actually end up getting this angle right here, a negative angle. Well, if I take that negative angle and I add 180 to it, I'll get the angle in quadrant 2 that I really want. Now let's say I have a quadrant 3 angle, and its components are both negative. So that means when I do inverse tangent of y over x, I'll be doing inverse tangent of a positive number, which means I'll really get this quadrant 1 angle. And if I want to find the quadrant 3 angle that I'm really looking for, I have to add 180. Now if I'm in quadrant 4, I would have a negative y and a positive x, and this would give me inverse tangent of a negative trig value. I would get this negative quadrant 4 angle. But let's say I really wanted to know the positive angle here. I would have to add 360, and let me redraw that. Let's say I really wanted to know the positive angle here. Well, what would I have to do? I would have to add 360 to my original angle to get the positive angle that I'm looking for. So plus 360 to the negative angle gives me the positive angle in quadrant 4. So this is useful, but you also have to draw a picture and think about what you're looking for when you're dealing with angles other than quadrant 1. Okay, I'm going to stop this video now here, and that's kind of an introduction to some of the terminology and the formulas and what a vector is. Now we're going to do some example problems on the next video.